Section 5 from Chapter 8, Area of Composite Figures. So we're continuing on with our area measurements. So just a reminder that all your answers are going to be the unit, whether that be meters, squared, or inches squared. Always need that little squared piece in your units. So we're talking about composite figures. What is a composite figure? A composite figure is a figure or shape that can be split or divided into basic shapes. For example, if you have a shape that looks like this, we have to find the area. We can cut that. We could take a scissors if we wanted. We could cut that right there, and we would end up with a rectangle like this and a rectangle like that. So we're splitting our one bigger shape into smaller shapes. So how does it help? If we can break things into basic shapes, we can use the formulas that we know to help find the area of those. So if you remember back, formula of a area of a rectangle, so area equals length times width. Formula of a parallelogram, area equals base times height. Now, these two formulas of a rectangle and a parallelogram are very similar to each other. Length and width, base and height, those are just different names for those. So if I were to draw a rectangle, we would have length and width. If I were to draw a parallelogram, we would have our base, and then a lot of these will have like a dotted line here, and it'll say, here's your height there. So very similar formulas there. Area of a triangle. Now remembering that a triangle is half of a parallelogram, so we have our 1/2 base times height, or some of you said area equals base times height divided by 2. Always remember multiplying by 1/2 and dividing by 2 are the same thing. To put this in your calculator, you can do 0.5. That's fine. Trapezoid. Remembering that a trapezoid, if you were to take two trapezoids and put them together, you would get a parallelogram. So area of a trapezoid is area equals 1/2 times base 1 plus base 2 times the height. So if I were to draw one here, we'd have trapezoid does not have opposite sides that are parallel. So you would have like base 1 here, base 2 here, and we need to know our height. So there's our height. You take all those measurements, plug them into the formula there. The other way that trapezoid was written, some of you had area equals base 1 plus base 2 times height divided by 2. Again, multiplying by 1/2 or dividing by 2 are the same thing. I'll draw a triangle here as well. So if here's our triangle, we've got our base, and then we'd want to have our height here. So just keeping those separate there. So then when we look at a composite figure, we take this and we say, okay, where could I cut this? You could cut this in a couple different spots, and everybody's going to do it a little differently. If you wanted, you could cut it across this distance here. Or if that doesn't, you don't like that way, you can cut it this way. Okay? So either way works. So we're going to cut it this way for our example here. And now I have a shape that's like this here. And then I've got this bottom piece here. So we want to go ahead and label some things. We know that this is 1.5 centimeters. It's the same as this one here. Those two are the same. And then this height here is 1.8 centimeters. This guy and this one here are the same. And then of our little one here, well, if you look carefully, you notice they did give us a measurement here of 2 centimeters. So we know that one. That's our 2 centimeters. And then our height is 0.5 centimeters. And all of those come from our original shape. So now we can do the calculations. We would do 1.8 times 1.5 and 2 times 0.5 for those shapes there. And we would get for this one 2.7, and this one you would get 1. So we have our two different areas. Well, we're trying to find the whole shape, so we need to add our areas together. So if we get, let's call this shape like area 1 and area 2. So this would be area 1, area 2. So area 1 plus area 2 equals 2.7 plus 1. So then those together equal 3.7, and it's centimeters squared. So again, you have to find the individual shapes, then put them back together, which is the addition part. All right, so now we've got another shape here. One that's you can cut again a couple different ways. Some of you might want to cut it as a triangle, which is and a rectangle, which is totally fine. Some of you might want to cut it on that dotted red line that's already there and make it 2 trapezoids. I'm going to show you the rectangle and triangle one. So we have, here's our 2 shapes. We have a rectangle and we have a triangle. We know that the distance here on our rectangle is 8 centimeters. And we also know that the distance here on our rectangle is 10 centimeters. So that one we can figure out. So we'll call that area 1. So area 1 equals 8 times 10. So area 1 equals 80 centimeters squared. Now our second shape, this triangle, we have to find the base and the height of our triangle. So sometimes triangles aren't always sitting on the base that you'd like them. So let's make this, here we know this one is 8 centimeters because that comes from this measurement here. It's the same distance over here on our rectangle. So we have 8 centimeters. So area 2, I'll make this guy area 2, equals 1/2, because we got a triangle, times 8 times, now what is our height? So to get that, if you notice in our original drawing, from this dotted blue line to the top here, we don't have a number here. But they do tell us the total distance of this. That's 13 centimeters. So if it's 10 from the bottom of the from the left side of the rectangle to the right side of the rectangle is 10, and it's 13 the whole way, we would have a total of 3 left. So our height of our triangle here is 3 centimeters. So 1/2 times 8 times 3. So you plug that into your calculator, you would get 12 centimeters squared. So now we've got to add ours back together. So you would do your 80 plus 12, and you would get 92 centimeters squared. So remember, not every measurement is always given. Like this 3 wasn't. I had to figure that out. I had to use what I knew. 13 total minus my 10 gives me 3 left. Sometimes you're not given any measurements. Like in this one, there's no numbers on here. So you have to go in and figure out what those numbers would be. And let's just do that in a minute. So notice that the numbers on the bottom count by 2. So 2, 4, 6. So we can't just count 1, 2 along the bottom. We would actually count by 2. So 2 to 4 is 2, 4 to 6 is 2 more, so a total of 4 here. Then the height, this left side here, going up. 2 to 4 is 2, plus another 2, plus another 2, plus another 2, is a total of 8. Across the top, count by 2s, so 2, 4, 6, 8, 10, 12. Going down this side, 2, 4. Going across the longest base here, so we got 2, 4, 6. Coming down is 2, coming over is 2, and coming down is 2. Lots of numbers there. You don't always have to write them all in, but sometimes it's helpful. Does not matter to me how you cut this one. I would probably cut it into 3 rectangles, something like that. So we've got a tall one, and then kind of a medium, skinny one, and then one that's kind of laying down flat. Or 3 rectangles. So we know this one is 8 tall, 4 wide. We know this guy is 4 tall and 6 wide. This guy is 2 wide, and we have to figure out how tall. So if we're 4, if we look back at our original, we were 4 from here to here, plus another 2, so we would be a total of 6 tall here. So now we have 3 shapes. Area 1 equals 8 times 4. Area 2 equals 6 times 2. And area 3 equals 6 times 4. So we got area 1, area 2, and area 3. 8 times 4 is 32. 6 times 2 is 12. 6 times 4 is 24. Then you would have to add those up. So add all your areas together, 32 plus 12 plus 24. So let's see, that gives me 30, 40, 68. 68. And because I didn't give us a number here, or a unit amount, as in centimeters, inches, we can just call it units squared. Break the pieces up however you feel comfortable. For the assignment, I think I got the right page numbers this time. Page 362 it starts on, ends on page 363. 1 through 7 and number 9. Let me know if you have any questions. Thanks.